All right, so this is quiz number 24. So let's just take a look at the problem here. We want to find V0, which is this guy. And so that voltage is going to be the same as the parallel, or the voltage across this parallel combination of the inductor and the capacitor and the resistance. And so if we could convert this into an impedance and this guy into an impedance, then we could just do voltage division, kind of like what we did on the last problem. All right, so let's go ahead and do that. So we're going to convert to the polar domain. So VG, and if we look down here, VG is 10 4,000, so that in polar domain is going to be 10 angle of 0 degrees. We're going to have a 4 kilo ohm resistance, and then we're going to have an impedance, and Z for the capacitor is going to be minus J over omega C. And we might as well write for the inductor here. It's going to be J omega L, and omega is 4,000. Okay, so we're going to have, then an impedance, an inductor, and a resistor, and this is 10K. So I need to find the inductance, or the impedance for the capacitor and the inductor. So 25 nanofarads and 2 henries. So I'm going to come back here. My frequency now is 4,000. My capacitor was, I've already forgot. I think my inductor was 2 henries. And my capacitance is 25 nano. So capacitor is going to be 25 e to the minus 9. And then my resistance, let's go back. What's my resistor? 4K. So might as well put all that in here. 4K, is 4,000. And actually, I'm going to just go ahead and put in what Vs is. So Vs is going to be, I'm going to convert it into rectangular, and what was it, 10 0 degrees. 10 and, and 0 degrees. All right, and then I'll go ahead and print out the ZL and ZC. So if I run those, ZL is 8,000J, and ZC is minus 10,000J. So ZL is, this was minus 10,000J, and this was 8,000J, right? 8,000J minus 10,000J. Okay, so here we've got the minus 10 kilo, minus J 10 kilo ohms, and here we have J 8 kilo ohms. So everything's are in kilo ohms. All right, so then when we convert this into impedances, again we'll have the 10 phase 0. That's Vs, and then I'm going to have an impedance here and an impedance there. And let's call this Z1 and this Z2. So Z1 is going to be the serial combination of the resistor and the capacitor, and then we'll call this R1 will be 4K and R2 10K. So let's come back up here. This is R1, and then R2 is 10K. R2 equals 10K. Okay, and then if we come down here, we say, okay, Z1 was equal to the serial combination of R1 and the capacitor. So this would be ZC. And then the second impedance, so this would be Z2. Let's see, I guess that needs to be a Z2, is going to be the parallel combination of R2 and ZL. Let's just go make sure that's true. Okay, so Z2 is going to be the parallel combination of ZL and R2, and Z1 is the series combination of R1 and ZC. So we can come back here, we can print Z1 and print Z2. Let's see what happened. Oh, I need to come back and rerun that guy, and then rerun that guy, and then rerun that guy. All right, so Z1 is going to be 4K minus J10K, as we expect. So this is going to be Z1 equals 4K minus J10K, and then Z2 is going to be 3.9K plus J 4.9, 3.9, 4.9. So this is like 3.9K plus J 4.9. Just make sure we got that right. Okay. All right. And they're just, in our computer anyways. So this is going to be, that's V0. So in, V0 is going to be Vs times Z2 over Z1 plus Z2. So I could write that out as, 10 0 degrees. This is actually 10 plus J0. So it's going to be 10 times, and then Z2 is going to be the 3.9K plus J 4.9K. And then on the bottom, we'll have 3.9K plus J 4.9K. And then Z1 is 4K minus 10K. So if I come back here and I do, Z0, 0 equals, and then I'm going to do Vs times, and then I need Z2 divided by Z1, plus Z2. And then I'm going to print out, and I want to print this in polar form. So I'm going to do polar and V0. And I get 6.63 phase of 84. 6.63 phase of 84 degrees. Oh, and luckily that kind of fits here. Okay, so V0 of t then is going to be 6.63 cosine of omega t, which is, remember my omega here is 4,000. So 4,000 t plus, and then 84 degrees. And the units are in, remember the units up here. Oh, actually, it didn't even give us here, but I'm assuming that's volts. So this would be units of volts. Okay, that's how to do